In this video, I'm going to demonstrate how to use Open Liberty and Microprofile to build resilient Java EE based microservices. Open Liberty provides developers with proven Java EE 7 technology and the latest Eclipse microprofile capabilities for developing and building microservices. During the demonstration, we will leverage the following core microprofile capabilities for building microservices. JAX-RS for creating Java EE REST service endpoints. JSON-P for working with JSON objects that are produced by the service. CDI for injecting scope context and bean dependencies into the service. However, the demonstration will primarily focus on the microprofile capabilities that provide resiliency to our services, such as fault tolerance, including annotations such as Retry, Timeout, Circuit Breaker, and Fallback. We'll also talk about health check for assessing the health of the service, and config for injecting external configuration into a running service in which the service can act upon. For this demonstration using Open Liberty and the microprofile features mentioned in the introduction, I'm using a Java microservice with a REST endpoint. The application I'm using is a books application that provides an endpoint to be able to list all the books, or add a book into the catalog, or to list a book by a particular ID. Notice that we use JAX-RS annotations to indicate the path to a microservice. We use context dependency injection to apply the scope to the microservice, and we also inject additional beans into the application that's needed for this particular microservice. Notice the microservice call to list a particular book by an ID, where we append the ID into the path. This is a JAX-RS get method that produces JSON as the output. Okay, so in the demonstration, we're going to focus on some of the microprofile capabilities that allow us to build resiliency into our microservice. In the example, I have an application, as I mentioned, the books application. If I list all of the books on the endpoint, you'll see that I have a catalog of books that includes just 2 books. I can also drill down into and pass in a particular ID of a book and list one of the particular books in the catalog. So what I want to do in the demonstration is focus on cases where the application may not work exactly as designed, and what we can do using Microprofile and Open Liberty to build resilience into the application. So for example, one of the first things I want to focus on is the retry capability in Microprofile. Retry gives us an ability to, in cases where the application may intermittently fail, maybe a little network glitch or something of that nature, that we could potentially retry the call to the microservice and it would work. So in this example, what you'll see is that sometimes my application works, and sometimes it actually produces an error, and it's rather intermittent in regard to how it functions. So this is a case where perhaps if we were just to provide a retry capability in invoking the microservice, we might actually provide a reasonable response back to our client, and they would never know that there was a particular issue. So for this, we have a retry annotation with microprofile. The retry is quite simple to use. We can basically just determine and specify the maximum number of times we want to retry the service invocation. We can optionally specify any kind of exceptions or errors that we want to retry on. But in this case, in my intermittent scenario, if I tried to do this 4 times, presumably my application would work and provide a seamless response back to the client. So again, we go and we run the application, and this time, every time I run the application, you see that I get a response back to the client. But what you'll notice is that in the output in my console and my server, every now and then when I invoke the service, it's actually down. But my client doesn't know because we're just simply doing the retry. The next thing I want to look at is timeout. Timeout is a case where maybe sometimes we have our microservice that takes too long to respond. And in this scenario, we don't necessarily want to wait for an indefinite period of time for our microservice to respond. So in this case, when I run, sometimes I simulate a slow response. Here I'm waiting for the service to come back. Seems like it took about 5 seconds. Sometimes it works pretty fast, and then sometimes it's really, really slow. So what we can do in this particular case is we can specify a timeout situation using Microprofile to say if our microservice is going to run longer than some specified period of time, and the time that I've specified is a half a second, then what I'd like to do is just go ahead and time the call out. Okay? So with the timeout, what we see is the experience is that sometimes my application works and sometimes it fails. But when it fails fast. So we're not waiting the 5 or 6 seconds or some indefinite period of time. We're just failing with a timeout exception. And you might think, well, that's not too good, you know. We're just coming back with an exception to our client. Well, this is where we can take a look at another fault tolerance capability in Microprofile that we can use in conjunction with retries and timeouts. And that's the fallback capability. Fallback is kind of cool. Fallback allows us to specify some alternative action that we want to take in the event of an error or that we couldn't invoke the particular microservice that we were looking for. So in this case, when I time out, instead of taking a very long time to run the microservice, we'll time out, fail fast, and then we'll call this alternative method, fallback method, to get a list of books. So this could be a case where if the client was trying to invoke a service to get information on a book on microservices and we couldn't get that particular information on that book, maybe we would send back a list of other books that are in our catalog related to microservices and that kinds of technology. So in this scenario, the application or the microservice is responding something to the client. We get the information for the specific book when it's working. If it's going to time out and take too long, we just go back to the fallback method and list alternative sets of books. So the next test I want to do is a circuit breaker test. Circuit breaker is interesting in that it gives us the capability to not call a microservice if we know there's a high chance that it's not going to succeed. In other words, we have a microservice that we know is not responding. Instead of just continue to call a microservice, let's just open the circuit and not call it until some predetermined time in the future. So in the circuit breaker scenario, we have a case where the microservice sometimes works and sometimes the microservice doesn't work. So you see in some cases I'm getting a runtime exceptions. Other times the application is working. And the way I set this up is it fails about 50% of the time in this particular test scenario. So with the circuit breaker, what we can do is add an annotation to not call this microservice if certain situation arises. In this case, we say how many requests do we want to have run before we consider opening a circuit, no longer calling. In this case, 2. So if I run twice and I get a 50% failure on this microservice, I want to open the circuit and not call anymore. Furthermore, I can define a delay saying that I want to continue to not call this service for, in this case, 10 seconds. So this is how this looks. What happens is sometimes it fails, and when it fails, I get a circuit breaker exception, which means I'm not going to call this service anymore. So I can keep invoking this service. I'm running it multiple times, and it won't run until that delay period exceeds. So in this case, that 10-second timeout, right? So after I wait about 10 seconds, I try it again, my service works, okay? So we get the circuit breaker exception, and again, this is another opportunity for us to also leverage the fallback capabilities in the microprofile, in that if we know that particular service isn't going to run, why don't we fall back and run a different service? And so in this case, I call the same service that lists all the books. So that's the capabilities that I wanted to showcase around the timeout and the retry and the circuit breaker and the fallback. The next thing I want to take a look at is health check in conjunction with some external configuration being injected into the application. For that particular scenario, what I have is health check endpoint that when run, it will tell us whether or not our service is up or down. And in my scenario, I'm checking 2 different things. I'm looking to see if there's a minimum number of books in the catalog, in this case 2, which would indicate my catalog is populated. And then I'm also looking at something called is healthy flag. Is healthy is being determined by whether or not my microservice is put into maintenance mode. So what I'm doing in my health check endpoint is actually looking at a property that's external to my application that says whether it's in maintenance mode or not. And this will get dynamically injected into my application, and I can take action on it. And then the other thing he's doing is he's actually making a method call to all the books and getting this number of books in the catalog. And so if both of these are okay, then I get the healthy endpoint saying my system is up. But in the case where I want to put my service into maintenance mode, I have this external property file, which is a JSON format. It can be anything you want. And so when I define this as being in maintenance mode as true, then I go back and I run my health check. What I find that it's not healthy and the system is down. So again, going back in and setting my microservice back available, rerunning my health check, and my service is back up. So that's a little look at the health check endpoint and actually injecting configuration into your running microservice so your application can take action on it. So that's the demo. Have a good day.